Hello coders, welcome to my channel. I am Aniket and today we will be discussing the problem number 1871 of LeetCode, which is known as Jump Game 7. Let's read the problem first. You are given a zero indexed binary string S and two integer minimum jump and maximum jump. Binary string are those string which is consisting of zeros and ones only. In the beginning, you are standing at index 0, which is equal to 0. Means if you are at 0th index, then that value is guaranteed you to 0. 0 value is present at 0th index, not 1. You can move from index I to index j if the following conditions are fulfilled. Let's see the conditions. You can jump from I to j if j is in bound, is in the range of I plus min jump and I plus max jump. So j can be in the between of I plus min jump and I plus max jump. What happen if max jump, I plus max jump is out of bound of the array? So in that case, you consider the length of that array as the upper bound, not I plus max jump. I hope you understand this condition, and uh, you only jump from I to j if jth index is containing 0. You don't need to jump from I to j if j index is equal to 1. You can only jump if jth index is equal to 0. Returns it true if you can reach index s dot length minus 1 in s, or false otherwise. So you should check whether you can reach last index of array or not. If you are able to reach at last index from 0 to last, then you should return true. If you are not able to do that, then you should return false. Let's try run this test case and give the intuition. First, you are at 0th index. Let's uh, write this test case separately. 0 1 1 0 1 0. First, you are at 0th index means here, and the min jump is 2 and max jump is 3. So from this you can go to 0 plus 2 means to second index, to 0 plus 3 means third index. So you can go 0th index to this and this index. So if you carefully see, can you jump 0 to 2? No, because if you jump 0 to 2, then this is containing 1, but you only able to jump if that is 0. But here the second index is containing 1, so you should return if s of j is equal to 1. As you can see here, the third index is 0, so you can process it further. You cannot return because here is it is 0. So from 3 you can go to 3 plus 2 means 5, or 3 plus 3 means 6th index. So if you are at 3 means here, then you can go 3 plus 2 means here, or 3 plus 3 means here. But here the arrow is out of bound, so you should return. You should take maximum value means you should take the length of the array s dot length minus 1, that is 5, not return. Do only uh, you will take this as 5 not 6, because the upper bound is s dot length minus 1 in this case. So if you carefully see, you are able to reach at fifth index. If I indexing it, it is 0, it is 1, it is 2, it is 3, it is 4, it is 5. And if you are able to reach fifth index from zeroth index, then you should return true. So in this case, you will return true. Let's try another test case also. 0 1 1 0 1 1 1 0. Initially you are at zeroth index and you can go up to min jump 2 means 0 plus 2, and max jump 3 means 0 plus 3. 2 to 3 there are two numbers, so there are two branches. If you anyone question you that how many branches can be generated from a single node, so it is max jump minus min jump plus 1. Here as you can see, max jump is 3 and min jump is 2, and if you do 3 minus 2 plus 1, so there are this number of branches can be generated from any node. Here this value is 2, so the branches number of branches from any node is generated is 2. So in this case also it is generated number of branches 2. So if you carefully see the second index, the second index is 1, so you should return because you cannot process it further. And if you see third index, then you can process it because here the third index is 0. If I do indexing 0 1 2 3 4 5 6 7, the third index is 0, so you should process it further. And if you process 3, then the next branches is 5 and 6. If you carefully see 5 and 6, both of them are 1, so you should return to the previous. And the all branches are terminated, so you cannot reach at the 7th index. You can't reach at 7th index. So here in this case you should return false because you are not able to reach at the last index from first index. So in this dry running of these test cases, you will surely get the intuition of BFS. BFS stands for breadth first search, where you process all branches of a node, and if you found the last index at any branch, you can return true. Otherwise you should return false. I hope you get the intuition of BFS. Let's try run this test case also, which will give you the major problems that this simple BFS will not solve. Let's write the this test case again. 1 2 3 4 5 6 7 8 9 10. 7 8 9 10. Here I write the same string as above, and if I indexing it 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. If you do from your BFS from 0th index, then from 0th index you can go to 1 to 3. How many branches will be generated? 3 minus 1 plus 1 will give you 3 branches. So there are only 3 branches at every node possible. So from 0th index, where you can go, plus 1 means 1 index, plus 2 means 2 index, and or 3 index. 1 2 3 means 1 to 3 you can go from 0. If you see 1 and 2 are 1, so you should return because you cannot process it further. If you see 3, 3 is a 0, so you can process it further. So here also there are 3 branches, and from 3 you can go 3 plus 1 means 4, 3 plus 2 means 5, and 3 plus 3 means 6. And you can see 4 and 5 both are 1, so you cannot process it, and uh, you cannot process it. Let's make this 6 as 0 to get our observation very clear. So as you can see, 4 and 5 both are 1, so you cannot process it, so you should return. But at 6 there is 0, so you can process it. So at 6 there are also 3 branches, 6 to 7, 6 to 8, and 6 to 9. If you carefully see 7, 8, 9, 3 of them, all of them are 0, so you can process these 3. So if you process these 3, then 7 will process 8, 9, and 10, and 8 will process 9, 10, and 11, and 9 will go deeper to 10, 11, and 12. If you carefully see 8, 9, 10 is also 0, 0, so you will process it further 9, 10, 11, and you process it further 9, 10, 11, 12, and all of the nodes will get 3 branches, and neither of them will be negated because everyone is 0. So what intuition you get from this? The intuition is, observation is, if you process seen elements again, you will result into MLE. MLE means memory limit exceeded, because as you know, in BFS we use a queue to process another level. So uh, if you put 8, 9, 10, 9, 10, 11, 10, 11, 12, then again 9, 10, 11, 10, 11, 12, and further, the queue will be result into memory limit exceeded, because you add duplicate elements into that queue, so it will result you memory limit exceeded. What you can do, we can use visited array to track seen and unseen, just like us normal questions. We should do visited I, we should use visited I to track seen and unseen, to get rid of this error memory limit exceeded, so that our queue will not explode and contains only distinct element, so that our queue will contain only distinct element. So if you do that concept in it, that the number of branches will changes drastically. Let's take the example, this example. If you uh, see 6, then you can go to 7 and 8 and 9. I will do this branch with this optimization and draw it here. If you do 6 branching, then 7, 8, 9, and you mark 7, 8, 9 as visited. When you do 7 to 8, 9, and 10, you will go to 8, 9, and 10, but you will not process 8 and 9 again, because you seen it at above level, so you should return from here only. You only process 10. So in this case also you will process 9, 10 and 11. So as you can see, 9 is already seen in the above level, so you should return from here and you should process 10. You should not process 10 also, because 10 is seen in the 7th branch, so you should return and you only process 11, you only process 10. And in this case also, if you do 3 branches 10, 11, 12, then you do not process 10 because you see 10 in 7th branch. You not process 11 because you see that 11 in 8th branch. You only process 12, so here it is 3 branch. So the number of branches reduces drastically by using visited array. I hope you get the significance of visited array. With visited array optimization, you can rid of memory limit exceeded, but there is one more point, that it will result into TLE. Visited array optimization will result into TLE. Why? Because for every node, you are forced to check, for every node, you are forced to check all branches. And what are the number of branches? The number of branches is max jump minus min jump plus 1. And if the node is n, so the complexity will become n into max jump minus min jump plus 1. So here the complexity is very large, and it might be possible that you check repeated elements again and again, you check repeated nodes again and again, like this. In this case, you check 8, 9, 10 for 7, and then for 8 you check 9, 10 and 11. 9, 10 is common in this and this, both of them, and it is very large because two of them is containing in 8th branch. Similarly, in 9th branch, 10, 11 of 8 is containing in 9th branch also. So this will give you the complexity of n into max jump minus min jump plus 1. How can you rid of this? So what is the main objective? We only want we want we only want single processing of each node, no other processing. Means we want, if we are checking 8, 9, 10, then we not want to check 8, 9, 10 again. We will check from 10th onwards, so we will check from 11. So we can use farthest pointer, we can use farthest pointer to rid of them, farthest pointer, which will result into O of n complexity. How? Let's see this with this test case. So in this case, uh, 0 is giving 3 branches, so the farthest pointer will be at third index at first level. So the next time 3 will branch from farthest index plus 1 to start, will go to farthest plus 1 to next, to the next node. So here the farthest is 3, from 0 you can go up till 3, so the farthest is 3. In next case, the 3 will not process 4 or 5, it will process farthest plus 1 to next node. So if you carefully see, farthest plus 1 is 4, so 3 will process 4, 5 6. So it is good in this case. And if you see that here for 3 the farthest will changes to 6, because from 3 you can go up till 6. So the farthest will go to 6, and from 6 you should check farthest plus 1 to the next node, 7 to 8, 7 to 9. So it is fine in this case also. And if you check again 7, so 7 will do farthest plus 1. Here the farthest is changes to 9, because 6 result into up till ninth index. 6 can go up till ninth index, so the farthest will result into 9. So if 7 is there, so the seventh, this branch, what is the result of this branch if you do farthest optimization? So the seventh, eighth, ninth is as it is, but because farthest is 9, so you can only process 10 to end. And you can see there is the last element 10, so you cannot process further, so there is only one branch 10, not 8, not 9, because farthest plus 1 is 10, and you will process 7, uh, seventh branch as 10 to 10. And if you see eighth branch, then the farthest pointer is updated to 10 because of 7. And if you do eighth branch, then the farthest pointer can go up till 11 only, not 9, not 10, because 7 is containing 10. So no need of do two extra branch, 9 and 10. So here 8 will go up till 8 will process only 11, 9 will process only 12. As you can see, this farthest pointer will reduce the branching even further and give the complexity of O of n, because of every node is branched with unseen node, so that every node is processed only one time. So these branches will occur only n times. So the complexity will be O of n. Let's discuss our code about this intuition. Here is my code. Let's discuss the code. Here is my code. Let's discuss it. Uh, Here I store s dot length into n variable and initialize the queue, because in BFS problem we use queue. Initially I add zeroth index into my queue, because the starting point is 0, and initialize my farthest pointer to 0. And I initialize the visited array to get rid of the MLE error, memory limit exceeded, till q dot is empty. I only do the classic uh, BFS traversal. If at any case the top element of queue is last index, then simply return true. And if it is not possible, then simply return false after all traversal of complete traversal of the tree. And initially I initialize my start pointer as the math dot max of top plus min jump comma farthest plus 1, as I already discussed in the above intuition. And the end is same as the question description, top plus max jump or n minus 1, which one is minimum, is stored in end variable. And I uh, do a for loop from start to end, and if the character is 0 and I do not process it earlier, So I will add it into the queue and mark it visited, so that our queue will not result into memory limit exceeded. And after all iteration, I will update my farthest is equal to n to get the complexity of O of n. I hope you understand my code. Please like, share and subscribe. This type of video is taking lot of efforts so that you can understand each and every crux of the problem. I hope you like it. Thank you for watching my video.